This is the foldable for section 6.2, substitution. We're going to start with the foldable facing this way, and we're going to fold it towards the words. We have some possible scenarios. Again, this was the section 6.2, substitution, and we got some possible scenarios. And what we're looking at here is when we have two equations that are going to intersect. If they intersect, then we have a solution. We remember by section 6.1, we have the intersection that was the order pair, just for example, -3, 2. That means we had an x and a y value to tell us where that coordinate was. All right. So here what we're doing is solving the system by some algebra. This one's called substitution because you're going to substitute in values and we're not going to graph them. So it says one equation is said equal to a variable. What does that mean? That means that you have y equals or even x equals. When you have a situation like this, we're ready to substitute. So we're going to write x plus 3. And then instead of writing the y variable, we write the value of y, which is 2x plus 1. So that was the y value. So instead of writing y, we wrote the equation for y. But it's still going to set equal to -12. And then we're going to go through the steps to solve these equations. So let's take a look inside. Here you can tell we have an x equals. So that means that instead of substituting for x, we're going to substitute for y. We're going to write 5x minus 2. And then, and I made a common mistake. Sorry, it was an x value that it was going to be substituted in. So let's try that again. 5. So instead of writing the x, we're supposed to write the value of x, which is 3y minus 9. And the only reason that I have this marker is because it helps identify the substitution that I make. You don't need one when you do your work. And then minus 2y is equal to 7. Now we're going to do the distributive property. 5 times 3 is 15y. 5 times a -9 gives you a -45. And we still write the minus 2y is equal to 7. Now we're just going to go ahead, so we did the distributive property. Now we're going to go ahead and do combine like terms. So that would be 15y minus 2y, which gives you a 13y. We're going to write down that minus 45 again is equal to 7. Now we're going to add 45 to both sides. 13y is equal to 52. We're going to divide by 13 to both sides. Y is equal to 4. But we're not finished there because that is just the y coordinate of our intersection. Now we need the x coordinate. The easiest one to substitute it back in is that first equation because it's already set to x equals. So we're going to write x equals 3. And we have the value of y, which is 4. So we're going to substitute in 4 for that y variable. And then minus 9. X is equal to 12 minus 9. X is equal to 3. That means that we have the order pair 3, 4 as that intersection on the graphs. And that is the solution to the system of equations. So we're solving systems by substitution. And you can tell we substituted in here and we substituted in here. So remember what you're looking for is a y equals or an x equals. It doesn't really matter if it's the first equation or the second equation, x or y. But once you find it, you're going to take the other equation, which in this case is the -6x plus 3. And instead of writing the y variable, you're going to substitute in the value for y. And remember on that first one, I had made the mistake of substituting y again. So we gotta be careful. We're substituting y because it's a y equals. And that's still equal to negative 12. So you can tell that that's the first equation that I wrote, but instead of writing y, we substituted that value. Now we go through the operations to solve for x. Negative 6x, and then a positive 3 times 2x gives you a positive 6x. 3 times a negative 4 is a negative 12, and that's equal to negative 12. Now we're going to combine like terms. That is a negative 6x plus a positive 6x gives you a 0x minus 12, and that's equal to negative 12. That means that we don't need to write it. 0 times x is just 0. So we're left with negative 12 is equal to negative 12. Well, that's true. That's true all the time. Negative 12 will always be negative 12. That means that there's infinite solutions. To remind you, this is where we had the exact same line. So this line is supposed to be the exact same line as this one. Well, you don't need this, but let me just show you. This is not part of the substitution method. I'm just reminding you that when both of the equations were the same, is that we had infinite solutions. So what I'm doing is solving for y, just to show you that they were the same equation. See? And they were the exact same equation, and that's how we also can know that they're infinite solutions. But this is the method by substitution. So we're going to substitute in that value. Okay. So what happens if no equations are set equal to a variable? What you want to do is solve for one. I'm going to circle this y because it doesn't have a coefficient. That means a number in the front of it. So that's the one that would be the easiest to solve for. It doesn't matter if it's x, it doesn't matter if it's y. It wouldn't matter if it's the first equation or the second equation. So let's fix this. We have to fix one of these equations so that one of the variables is solved for. So we're going to have 2x plus y is equal to 10. And just subtracting the 2x from both sides is going to give you y is equal to negative 2x plus